Hello friends, myself Rajendra Mahajan presenting my video on characteristic equation and eigenvalues of matrix. Let us solve the problem. Find characteristic equation and eigenvalues of matrix A as 2 minus 2 3 1 1 1 1 3 minus 1. Before to start the solution, please watch the video up to the end. Also, I am providing the link of my previous videos on matrices. You can watch that also. Characteristic equation is given by determinant of A minus lambda I is equal to 0, where lambda is any scalar quantity and I is the identity matrix of same order. Here the order of this matrix is 3 by 3. There are two different ways to obtain the characteristic equation, either by evaluating this determinant or we can use the shortcut method. By that shortcut method, characteristic equation is obtained by lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0, terms alternately positive and negative, where s1 stands for sum of the principal diagonal elements a11, a22 and a33. If we take a sum of this, it is the value of s1, and s2 is the sum of the minors of the principal diagonal element, means we have to obtain the minor of a11, minor of a22 and minor of a33, and if we take a sum we get the value of s2, and the third one is the determinant of A. And if we substitute all these values in equation 1, we get the required characteristic equation. Therefore, performing the calculation for this particular example, principal diagonal elements are 2, 1 and minus 1. Therefore, the value is 2 for S1. Then we find S2. It is the minor of first principal diagonal element, that is 2, plus minor of second principal diagonal element 1 and third diagonal element minus 1, minor of minus 1. The minor of the first diagonal element, we have to neglect the first row and first column. The remaining elements 1 1 3 minus 1 1 1 3 minus 1. Determinant of this is nothing but a minor of 2. Then neglecting the second row and second column, the remaining elements are 2 3 1 minus 1, 2 3 1 and minus 1, and plus minor of the last minus 1, neglecting the row and column containing it. The remaining elements are 2 minus 2 1 1, 2 minus 2 1 1, 2 minus 2 1 1. Evaluate it, we get minus 1, 3 1s are 3, minus 3, plus minus 2 minus 3, and plus 2 minus minus, it becomes plus 2, and therefore values is minus 4, minus 5 and plus 4. Minus 4 plus 4 get cancelled, and we get the value of S2 as minus 5. Okay. Then determinant of A. It is the determinant of 2 minus 2 3, 2 minus 2 3, 1 1 1, 1 3 minus 1. Evaluate as usual. We are evaluating the third order determinant. Therefore, 2 into, neglecting this row and this column, determinant of this 1 1 3 minus 1. Therefore, directly I will perform that calculation. It is minus 1 minus 3. Then second element is minus, that minus and this minus will become plus 2 into, neglecting this first row and second column, 1 into minus 1 we get minus 1 and minus 1, and plus 3, neglecting first row and third column, we get determinant of 1 1 1 3 as 3 minus 1, and then evaluating it we get 2 into minus 4 plus 2 into minus 2 and plus 3 into 2, and therefore the value is minus 8, minus 4 and plus 6. Therefore minus 12 plus 6, we get the value as minus 6. Substituting all these values in equation 1, we get that equation. Therefore characteristic equation is lambda cube minus s1 lambda square. The value of s1 is 2. Therefore 2 lambda square plus s2 lambda. The value of s2 is minus 5 lambda, and plus minus plus, and then minus, determinant of a minus and dash minus, it becomes plus 6 is equals to 0. Therefore this is the required characteristic equation. We call this equation 2. Lambda cube minus 2 lambda square minus 5 lambda plus 6 is equals to 0 is the required characteristic equation, a cubic equation. And after getting this characteristic equation, we have to obtain the roots of that equation. That roots are called as characteristic roots or eigenvalues. Therefore it is a cubic equation. We have to solve it by synthetic division technique. Write down the coefficient in decreasing order. Here the coefficients are 1, minus 2, minus 5 and 6, and there are shortcut methods for plus 1 and minus 1. This is trial and error technique. If sum of the coefficient is 0, we get 6 plus 1, 7 minus 7, we get 0, and therefore 1 is the root always. Directly we can go for 1. Taking the first element as it is 1, then 1 into 1 we get 1, sum of these two as minus 1, a product as minus 1, sum is minus 6, again product of minus 6 into 1 we get minus 6, and the last sum is 0, and as last sum is 0, 1 is the root. From cubic equation, if one factor is removed, the remaining equation is, or remaining factor is lambda square minus lambda minus 6 is equals to 0. Finding the factors of this, sum must be minus 1 and the product must be minus 6. Therefore lambda minus 3 and lambda plus 2, product is minus 3 into 2 is minus 6, and minus 3 plus 2 we get minus 1. Therefore these are the remaining factors, and therefore equating each to 0 we get lambda is equals to, the first root is 1, second one is 3 and minus 2. Therefore, or we can write as per this order, first minus, minus 2, then 1 and 3 are the eigenvalues. Then there are two important properties for that eigenvalues. We check it, and if that properties are satisfied, we can say that the obtained values are correct one. The first one is sum of the eigenvalues Here that sum is minus 2 plus 1 plus 3. That sum is 4 minus 2 is 2. Is always equals to sum of the principal diagonal element. What are the principal diagonal elements here? 2, 1 and minus 1. 2, 1 and minus 1. Therefore, 1 minus 1 get cancelled, we get 2. Therefore, 2 is equals to 2. That first property is satisfied. Once again, I will repeat that property. Sum of the eigenvalues, if is equals to sum of the principal diagonal elements, then the values are correct one. Or this is the property for eigenvalue. And the second property is a product of eigenvalues is equals to determinant of E. Here the product is minus 2, 1 and 3. And determinant value is minus 6. Therefore, this product is also minus 6. The second property is also satisfied. And if these two properties are satisfied, then whatever the calculation you have performed is the correct one. Means we get the correct equation and also correct eigenvalues. Means you can confirm your marks by checking these two conditions or two properties for eigenvalues. One more problem I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.